Now the time has come to actually calculate the line that best fits the points. So we know how to get R, we know how to tell if our data is linear, and now we want to come up with the line of best fit, okay? And it's a basic linear equation. It's going to follow the form y equals mx plus b. And this is where if you have a little bit of algebra knowledge, it'll be helpful because this is as deep as we're going to get into algebra in this entire course though. So y equals mx plus b, we'll talk about it later. All right, so it's called a line of best fit. It's also called a least squares regression line because the way that it best fits the data is it minimizes the sum of the residuals. Well, if you don't know what residuals are, then you don't understand what I just said. So we're going to define residuals. And the whole point of this is we use that line to make predictions, to kind of fill in the gaps of your data. And that's really what linear regression is used for, is being able to look at predictions. So a residual, you need to know how to work with a residual. It is the difference between the actual observed y value, like an actual observed data point, and what you predicted it was going to be. It's basically how far off was your prediction. So if the weatherman predicts it's going to be 80 degrees and it actually turns out to be 82, well, then there's a residual there because he wasn't right. The residual is only 0 if your prediction is dead on, okay? So here's your formula, and you've got to be able to keep track of all these y's. Actual observed y value minus predicted. And when you see the predicted y value, it's a y with a little party hat on top of it. It's actually called y hat. So a y by itself is the y value of a data point. Y hat is the prediction. If your residual is positive, it means that your data point is above average. Your data point actually turned out to be bigger than what you predicted it was going to be. If your residual is negative, it would indicate that what actually happened was smaller than what you predicted was going to happen. So it gives you a little bit of feel that way. All right, so we're going to use this example for the next couple pages. So like I always say, if you don't have the data in your calculator, pause the video, put the data in, and then come back and join us. I've already got the data in my calculator here, okay? But we'll use that later. The following data represent the club head speed and the distance a golf ball travels for 8 swings of the club. So they hit the golf ball around 100 miles an hour, right? And these were the distances that the ball flew, and we're not taking into consideration like wind and friction and all that sort of stuff. So this is just the distance, miles per hour and yards. And the way that they're listed here are X and Y, or list 1 and list 2, because the distance depends on how hard you hit it. It's not the other way around. The miles per hour don't depend on the distance. I guess that would come into play when you're choosing a club, right? But it's that the distance the ball flies depends on how hard you smacked it, right? Whether it was 99 miles an hour or 105 miles an hour. So what they've already done is given you the line of best fit. And all these little black dots, think of those as the actual golf balls, right? Those are the actual data points. And that's where they're sitting based on these club head speeds and these distances, okay? And then the blue line here, that is the line of best fit. And that's the line we would use for predictions, okay? Now, the residual is the little pink vertical line. So let me explain to you what a residual is on a picture. Here's what we predicted. If you hit the golf ball at 103 miles an hour, we predicted, based on our line of best fit, that it would go 269.3. The ball actually at 103 miles per hour went 274. So do you see how it's above the prediction line? That pink line is a visual for residual. Like that line, which would be 274 minus 269, it's positive, it's above, it's 4.7. The ball actually went 4.7 yards farther than we thought it was going to, so it's above average. Here's another place where you were above average. Here's another golf ball that was above average. Here's another one that was above average. And all these balls that are below the line, those would have negative residuals. You see how they hang below the line? So the ball didn't go as far as we thought it was going to. So all those little pink lines, do you see them? All those little pink residuals, we're trying to minimize the size of those. So if you've got the smallest amount possible on all those pink lines and you have minimized the sum of the residuals, then that's a line of best fit. But that's a visual of what a residual is, and I think it's helpful. We'll calculate some residuals later, but I think for right now, just kind of getting a visual feel for what it is helpful. So how do we interpret these values that we predict, these numbers that are on the line itself? Well, it can be an estimate of the mean value of y for a particular value of x. Or it can be an estimate of one single value of y for a particular value of x. So let me explain using this point here, 103, 269.3, because that was a point on our prediction line. It can be interpreted in two ways. You could say the mean distance of all golf balls hit 103 miles an hour, the average would be 269.3 yards for all golf balls. So you're like generalizing this to all golf balls based on your prediction. So you can have kind of that global interpretation. Or you could say the predicted distance of a particular golf ball hit at 103 miles an hour is 269.3. So you could talk about one individual golf ball, like I predict if I hit this golf ball 103 miles an hour, it's going to go 269.3 yards. So it can be for one particular instance, or it could be generalized for all golf balls. It's the average distance or the mean distance. So either one of those are correct. Okay, it's two ways that we can use these to predict. All right, so how do we get it? How do we get this regression line off of our calculator? Well, you already know where to go because it's on the same screen as R. And just like we said before, there's two options. I prefer option 2, but you have to have the diagnostics turned on if you go to option 2. But if you've been working with me through the previous section, you already have your diagnostics turned on. But I'll show you both. You can also go to LinReg t-test. That one just looks a little scarier because there's a bunch of stuff on the screen you don't know. And what we're going to be looking for is we're looking for A and B. If you remember on the output screen before, there was A, B, R squared, and R. And all we looked at was R. Now we're going to talk about what the A and the B are, okay? All right, so now's the time. Again, if you don't have the data in your calculator, you need to go put it in there. So here we go. I've got the data here in list 1 and list 2. I'm going to go to stat. I'm going to go over to, let me go to tests first and show you the one that's a little different. We have to go all the way down to F. It says LinReg t-test. Make sure it says L1 and L2 and then just blow past the rest. Don't worry and change anything else in there. And you get all this scary stuff on the screen, but what you're interested in is R. And now today we're interested in A and B, okay? A and B we're going to put together and create our line. Your line can look like this, A plus BX. Well, it depends on which calculator that you use. Let me see what this one has. Okay, if you go here, it says A plus BX. So if you're using LinReg t-test, you would write this for your prediction. And we're going to round all of these A and B to 4 decimals. So A is negative 55.7966. That would be A. And then you would say plus, and then you'd put in B and then end with an X. So B is 3.1661. This is the way that you would write the equation of your line if you did LinReg t-test. Okay? Notice A is the 55 number and B is the 3 number. Okay? And the 3 number is attached to the X. Now, the way I prefer is to go to LinReg, list 1 and list 2. And this gives you A and B, but notice what the difference is. Can you see the difference? Because of how they wrote it, A is the 3 number and B is the -55 number. So it completely matters which selection you pick on your calculator. I think this one's easier because it's already set up mx plus b. So in this case, you would write your prediction line as A, 3.1661, and then you'd put your x after it. And it says plus b. Well, b is negative, so plus a negative is minus 55.796. Okay. I want you to look at both of these. LinReg, and this is LinReg t-test. Okay. They look different, but they're the same line. I want you to convince yourself that these two are the same thing. It's just they took the piece with the X and the piece that doesn't have the X, and they switched them. That's all they did. This starts with the number, ends with the 3 point whatever X. This starts with the 3 point whatever X and ends with the number. I like this one better because it looks like MX plus B form, and I think that's going to be easier for you guys to work with. So that's going to be my suggestion. That's how I'm going to do it throughout the rest of the notes. Okay, so here's our prediction line. This is the one we're going to use. Now it says, predict the distance that a golf ball will travel if the club head speed is 104. Well, if you recall, club head speed is X, distance is Y. So if they're giving you a club head speed of 104, that's an X. You need to plug it in for X. So your prediction is going to be 3.1661 times 104 minus that 55 number. Okay, so let's see what we get on our calculator. I did quit to get out of that screen. So just type it right in your calculator. I use parentheses for the multiplication. 273.4778. And then you'd round that off however they want you to round. Let's just go 1 decimal here. 273.5 yards. So we would say, I predict if I hit a golf ball with a club head speed of 104 miles per hour, this is how far it's going to travel. Or all golf balls hit at 104 miles per hour will travel on average 273.5 yards. That's the 2 ways to interpret that. All right, so let's suppose that a golf ball is hit 104 miles an hour and the actual observed distance is 331. Like that's actually how far it went. That's the actual Y. Calculate the residual. Well, the residual, if you remember, is the actual minus the prediction. So the actual is 331. We only predicted it was going to go 273.5. So actually, it went further than we predicted, which means it's a positive number. It's going to be above average. I just answered part D, but it's going to be above average. 331 minus 273.5. 57.5. It went 57.5 yards farther than we thought, and that's a positive number, and so that distance is above average. If that value had been negative, we would have said below average. So that's how you calculate a residual. So you're going to, this is the whole section in a nutshell. Come up with a line, make a prediction, compare your prediction to an actual data point, and calculate a residual and tell if it's above or below average.